welcoming a fifth member in my family, which means, yeah, a son is coming actually. Guys, hey, guys, not baby number five. I'm saying the fifth member of the family. And I'm still young, guys. A fifth member, baby number three, yeah. And I have two beautiful young girls, and now their brother is going to land on Tuesday. So if it happens that my hands are not on deck, I will be able to do the session online. But otherwise, I don't think you should come here and do that next week. That one is confirmed. What I will confirm is either I will be able to do it online or not, because it will be a busy time. Right. Let me share the screen and then we comment. Thank you so much, guys. Thank you so much. Yeah, I have fun and all. Yeah, and stress. So, are we on exercise number seven? Yeah. Right. Number one. Yeah, this week is one of my busiest weeks whereby I need to finish an article by today. And you know how this stuff of my master's work is that you you never write actually. So it's the continuous thing until the submission last hour. So your supervisor always make you make a lot of changes. So yeah, that's what I'm going through as well. Sometimes it frustrates, honestly speaking. So now, okay, let's now start. We are required to, okay, the calculation for Christian forces, which I did already mention that we don't cover that. I want to ask one of my guys to help me for QK. I need help in QK. Still, thank you so much. Okay, so beverage crates are checked for completeness with the help of an inspection unit. The incomplete crates are pushed off the roller conveyor by pressing a push button. Problems occur repeatedly with the setup used thus far. the push button is not pressed long enough, and as a consequence, the single acting cylinder doesn't advance to the front end position. So in an event whereby you are using a single acting cylinder, there are times whereby when you press the push button and you let go, the cylinder might not extend to the fullest. It makes sense what they're saying here, and I've witnessed it a lot of times, whereby because of this thing, what it does is, as you press, it tends to extend. Then as you let go, that power generated is not there, especially with the two-way valve and my desk. It seems like they've forgotten that Fridays I run my lab. So the ejected beverage crates become jammed in the ejection area. Okay? So if we still remember very well, I touched on the issue of the end sensing capabilities. So there they are talking about that, whereby you extend something and it doesn't become fully extended. This is a typical example. Let me try to turn on this screen. As you can see, you people struggling. Turn off this screen. It's using a motion sensor. Yes. Right. So, apologies about that. We need to turn on additional screen. So, develop a controller with this problem, with which this problem can be eliminated. As you can see, the system here, that the system checks the completeness of the crates. When there's something missing, probably it alerts you. They are doubting to tell you that the system should do it automatically. They want you to use a push button. But in an event of an automated system, obviously, I've seen how fast conveyor belts can run. Therefore, that's why one of my targets, I need to really master analog signals, whereby when I teach you PLCs, we just start from analog signals. We'll do a hybrid whereby we mix digital signals and analog signals, so that you can understand that the conveyor speeds vary. And I will use the most latest version here, the software called Fix2IO, because the older version, the conveyor belts move really slow at their maximum speed. But the latest one, yeah, at times, remember, with Fix2IO, you kind of like, you're not sure how these sensors and timers must operate. Then you're like, okay, let me think. If it moves from point A to point B and point C, this must happen. And it moves very fast and you get confused. But if you are using that system as an analog, you will be able to control the speed. So, and then at maximum, you see that no, this thing is really moving fast. So at times you can create what they call buffer stations by creating a diversion whereby the one side of the conveyor runs at maximum, the one side runs at a slower speed. So that one will be a buffer. If there is some delays happening on the system, you don't want to affect the entire system. So we use what they call buffer. As much as you guys won't work a lot with production, but I feel like it's very important to understand the terminologies. Because first and first, they will tell you in industry that, hey, man, create a buffer there. And then you're like, what is a buffer? So yeah, it's designed to alleviate bottlenecks. Oh, bottlenecks. Bottlenecks is the station that delays the entire plant whenever you're producing anything that you're producing. Remember, you work at Clover, the other one worked at Tetrapet, the other one worked at mining companies and stuff like that. Whereby, like you will find that you have stations in a plant, and those stations need to run concurrently. I'll make it a simple example. At Ford, the entire plant ran constantly. And at times you find that you were a bit slow because you're not feeling well, and that belt will run. So you end up moving with it, and at times there are now cars coming to your station, and you're expected to be there. But at the same time, you realize that you couldn't finish the other cars, so you need to run with it on other stations because yeah, they do all Ford Ranger models in one station, on one line basically, all of them with all variety of colors. So from wild tech to your normal single cabs, you know, the 4x4s, the super cabs, everything. They do it in one single line. And you can imagine how complex that plant is. I think Ford is one of the most complex plant I've ever seen. And I don't know how are they going to produce the Ranger Raptor concurrently with the newer Ranger, because the Ranger Raptor has the older, it's the older generation, and then the newer Ranger is the current generation. But I know I've seen them doing marvelous stuff there on that line, and the Ranger itself had 31 types, basically 31 types. And remember, the moment they say wild tech, like for instance, you find that most engine spec you find it on all the different shapes. So every car model, maybe the ST, SX, whatever, up to the biggest one, they all have single cab, double cab, and stuff like super cab, and all those varieties. They all need to go in the same plant. 31 of them from the previous generation. This generation is going to come with another 31, and the wild track, the Range Raptor. So yeah, those guys are good. And they're doing Volkswagen in that plant as well. So it's going to be more complicated than it is. So the buffers, they work a lot inside stations because you need to be able to buffer the station. And they make sure that everything is equally distributed in the entire plant. And this concept can simply mean a buffer basically, because pushing it out of the plant doesn't mean that it's been thrown away. It just means that you need to add two more bottles and you need to be able to connect without hampering the entire process. So yeah, so that's why the buffers work, and you need to be able to create one and also to decreate, like meaning to reintegrate back to the main line. So I think those stuff you will, I don't know, because you guys no longer doing industrial once you get to BTech. Yeah, so mechanical guys used to come to industrial on BTech. On national diploma, they're like, nah, we don't take that course serious. They go to work and then they become bombasted with these terminologies that run plant. Remember, mechanical maintains plant, industrial runs the plant. There's a difference. We make sure that the target is achieved, and you make sure that I can achieve that. But then at times you get to be conflicted with terminology, strategies, and stuff like that. Then most of you guys tend to come and learn industrial modules. So you used to do it Capitech. So you leave away mechanical modules and do some of industrial modules. I don't know how are they doing the integration now, since we are living here with almost a BTech, maybe at honors level. I don't know. I've never heard anyone talking about doing industrial modules, but the at the managerial side of things is very important. The plant management is very important. You must have those skills. Even if you must do them at Udemy, please do them. Don't undermine industrial. It helps a lot of mechanical guys to be into leadership roles basically, because it's more of management. And if you have the background of mechanical, then you become an all-rounder. Actually, I feel like in the better industrials come from mechanical. Even our lecturers for industrial, like Dr. Jerome is purely mechanical lecturer. He's actually getting paid under the budget of mechanical. He's a pure mechanical guy, but he's now become one of the best industrial engineering lecturer. Even Dr. Abel Mashaba is now full-time industrial. Yet before he left here, he was a mechanical guy. And that's why all over the world these two departments are connected. Like, yeah, they kind of support each other. So that's one thing that in the past it was never addressed properly. We were made to be like, I can get a job when you can't, and stuff like that. There has been this rivalry that was so unnecessary. I don't know who was creating it, but that was lame. So the cylinder of the piston should advance as soon as push button is activated. There's no need of you cramming these letters that they're using. The code is different. I don't think it's smart enough. The SF1, no, no, no. Just say push button, PB start. Simple as that. And whenever we need a push button stop, we'll say PB stop. Okay. After the piston rod reaches the front end position and activates a limit switch, it should be retracted automatically. So basically, if it can't reach the front limit, it must never retract. So it must fully extend so that it is sure that it has pushed away the unwanted products. Then it can retract. So it needs to be sure that I've reached the end, the extended end position. This another person will say it will always do it, it will always push it successfully, but pressure in the cylinder varies sometimes. At times you use pressure regulators, then it will retract before time. So you need a sensor to make sure that it's fully extended. Being fully extended gives you a surety that the product has moved away from the plant or from the conveyor belt that is running, what do you call perpendicular to it. After the piston rod reaches the front end position and activates a limit switch, it should be retracted automatically. Okay, so we are going to use a double acting cylinder, and I did clearly say that I prefer not to say that we're using double acting cylinder, and I expect everyone to automatically or by default put a double acting cylinder. Can you help me set up 2K? I will now. Yeah, and I forgot it. Sorry. Thanks for coming. Okay. We forgot that my sister's going to the in of what's coming from. Let's see. Apologies, guys. I need to create a session for PK. In case the lab gets full, I need to be ready to redirect students that side. But it doesn't look like it's gonna be full, but better be safe than sorry. Okay, let's no problem. Thank you so much, Rose. Right, let's swiftly continue. Um, okay, they want us to use an end function. Okay, complete the circuit diagram list. Okay. Uh, okay, but I don't understand what's happening here. Control of the cylinder will be executed indirectly with push buttons. Looks like these push buttons are in plural. Okay, so I want to see. Advancing can only be started when the piston rod is at its rear end position. So we are sensing twice. We're sensing our initial sensing, meaning that the system will work like this. It will never extend if it's not at the rear end, meaning there must be a sensor there to confirm the location of the piston rod. Then it will never retract unless it's fully extended, meaning that if it's in the center, it's a jam automatically. So in the PLC, I would say to you, maybe take this as a test and say, sound an alarm in the case of a stand in the center. Then we use the software called Factor-O to simulate that error basically so that you can test it. Here you can't make it to stand on the center, unfortunately, because you don't control the cylinder manually. So in a second, we were going to block that cylinder halfway and then sound the alarm. But unfortunately, you can't on this one. It's designed to, or it doesn't do troubleshooting of problems. It doesn't create problems. There's a theme called troubleshooting in Factor-O, whereby you simulate problems so that you can work around those scenarios. So now it's straightforward, this one. Okay, for me. Where's this guy? Right. So new. What I believe I can't open that one. Oh, only 4. Which one is mine? This one. Oh, it's not mine. This one could be mine. Just let continue where I left off, but it's fine. So now, double acting cylinder, you are going to need a ruler and negotiable. Just put it on top, just like that. You don't need to, it doesn't need a perfect location, guys. Just put it on top. It doesn't need a perfect location. Okay? And then you close the mechanically operated and the pneumatically operated. You leave only solenoid valves. Okay? And then you take a double acting solenoid valve, the 5-2-way solenoid valve, right? Okay? The ones that I've never worked with is these ones. I don't know what they are actually doing. Like they look bi-directional, and I don't know what's the purpose of that, honestly speaking. Maybe when you are doing revolver cylinders, I'm not sure because they are the cylinders that can rotate. Maybe in that case, I don't honestly know.
So what's the difference between the one on top, the 5-2-way solenoid one, the fourth one on top?
This one, okay. The other thing that I didn't do was to explain. Let's start with the photo. The photo is not good. Let's try this one. Also, the photo is not good. So, what it means on this one is this is a double pilot, yeah? 5-2-way valve. This one is a single pilot 5-2-way valve. So now this one has a spring return. So you only actuate it on one side. Yeah? Then when you let go of that push button or whatever, it will go back to its initial stage because the spring will push it. So this spring remains for the retaining mechanism. So now this one, once you actuate this side, it means that it will extend and retain that position until you actuate this side. So it requires electrical actuation. So it returns by actuation. This one, it returns by single spring return. So it uses a spring return mechanism. So once there is no longer air pushing it, then it comes back. and most of the time the air is actuated by push button. So it means that when you press the push button and when you let go, it also comes back. Yes. So in future, I'm going to do election relay circuitry whereby we any of the two, we make sure that the electrical circuit can keep them constantly actuated until we cut the signal on the latching relay. To latch is to hold on. Simple as that. So I did mention this that guys, I penalize if you don't use what do we call this thing? The service unit. Yes, I heavily penalize. It's unacceptable. You shouldn't avoid it at all costs. You must put it. Avoid forgetting it. You must have it in your circuit. So the circuit is complete like that, and now we move to the electrical part. So you can put it close by because the circuit is a bit longer, and you paste it maybe somewhere there. Remember, I did encourage the borderline, don't cross it. If it happens that you cross it and you don't know what to do, try to I like to say it. Try to continue programming without stressing a lot about the border. I will give you part marks for a complete circuit than a circuit that is not complete. It tends to be a problem to find ways to give you marks if you know you cross the line, the border, and give up there. No, just continue messing up. It's difficult to generate some of the problems that students are doing because I normally know what I'm doing, therefore I do it right the first time. But I know students under pressure. Remember, like being examined through time is a problem. But those are a simulation of deadlines at work. You get it? So you're given 3 days to do something that you don't know, and it's for money. And if you can't do it, it's a warning. It's harassment and so on. So here we are simulating that through time. So I know you will panic and want to fix it a lot. Yeah, I can't simulate how the students are doing it. But once you try to fix your code, your diagram, most of the time it never stops creating those errors. I don't know why. Like it kind of requires you to delete everything and reconnect them again from one side to the other. So that's why I say if you see errors, just throw the circuit and complete it as the way it can make sense, and then submit. I don't want a situation whereby you fail because you couldn't finish. Okay, so now we're going to put the standard push button. Okay, although they mention push buttons with plural, German sometimes they just write English because yeah, but it's not supposed to. You need to have multiple push buttons if you want to talk about push buttons. So now this is start button. Yeah, it's complete. Let's put the sensor. And guys, some at times I've seen that they use this kind of changeover to represent the sensor. I don't have a problem with that. I just prefer this one. I think like they do the same work, the same job, because I don't confuse things. Okay, so I'm doing the second relay now, as you can see here, and I'm doing the thing. So now what happens is this is my B underscore start. Okay, so now This side is probably sensor extend retract. Yeah? So S0 maybe, or S underscore retract, reach. Okay, so this is for my sensor retracted. So this must be on the ruler. Remember, you can't actuate this. It's not like this one. You can't actuate it. Like I can press this, you see, but you can't press that. So it is only controlled by the ruler. So I will say S underscore retract. Then I say it's position 00, meaning that I need to measure position 00, and it does go to 00 as you can see there. So now if I connect like that, oh, that's why it doesn't connect. This was supposed to connect. The spelling matters, guys. Change your spelling changes everything. Due to the underscore, you see it is connected. You see that? So now, you see here, it is connected. The relay here is connected. And then the this push button now also is connected. So the two signals, they need to join. Ne? They need to join, we need to combine them. So what they said is when they are both combined, we want the cylinder to extend. So this one is always on whenever the cylinder is best position, and when we press the push button, the two needs to be in series in order for them to turn on. So remember, from here we are doing what? Changeover switches. Those are the ones we are doing in series. Are we clear? Yeah, don't worry. So now, remember, we're gonna have maybe relay. Okay, because there are plenty of relays, let's say R1 and then R2. So now, let's start with your maybe R1 and then next up your R2. Then from here, we're doing what? Now it's like we are taking now we're taking it to the solenoid itself. And we have your sol underscore 0 and sol underscore 0. So let's simulate. You see R2 is connected, meaning the R2 here is connected. And then now we just need to now connect the R2. If I connect the R1, then the whole circuit will be connected. There will be power coming here, and that power is going to come there, and then this will extend like this. Because it's a 5-2-way valve double pilot, it has an inbuilt latching circuitry, so that's why it's managing to extend. Look at this, the circuit here. The circuit is now off. You see that the circuit is completely off, but the system is fully extended. So there's no power on the electrical side, but the valve itself has an inbuilt latching mechanism. Therefore, it remains extended until we create another circuit to induce it this side. Okay, so now we're going to create a sensor, a similar type of a sensor. That sensor is going to represent our sensor EXT, extend. Yeah. So sensor at the extend position, right? And obviously we need a relay. The moment you copy a lot of stuff, you need to be sure. So I don't know. To be safe, we can always redo everything. But if you know what you're doing, copy is fine. Then this is my relay number 3. Then the relay requires a changeover switch. We did talk about the changeover switch that it represents anything that connects directly to the system, meaning it could be it gives power to the output, the actuators, such as your motor. So it can represent a contactor, and we spoke a lot about a contactor, and we spoke a lot about a relay as well. Without it, you might as well use a circuit breaker and you don't create that thing to be automated. And yeah, it's no longer going to be nice. So now, this sensor, which is, yeah, this sensor doesn't work. Let's do this. And then I come here and do this. Sensor 0, this one. Yeah, because the other one reads somehow. So R3 must always remember these A1 and A2 are always connected physically there. Therefore, that's why the R3 must always match there because they are physically connected. Same apply with Sol 1. Right? Solar network 1. They are physically connected to this. And then we position this. Okay, now this. The moment you change everywhere. Otherwise, we're gonna have a problem. Change everywhere. It needs to come natural. If you practice a lot, you won't have so much issues. At fully extended. Remember, we've used fully extended last time. Okay. So we have two positions there. The sensor 0 and the sensor 1. The other one represents extended. The other one represents the retracted. Okay? And I want us to regulate the speed. I think you must always do that. I will regulate the retracting speed again, once again, because it's easier to see. It automatically returns. I don't want it to return very quickly. Rather, we throttle the speed so that we can see the reaction. And I am positive we know why I'm positioning it this side. Okay, and then so the retraction will happen very slow. You see what I was talking about? Yeah, this is a problem. And most of the time, you guys make these problems. Uh, Kosovo, I'll open the platform for questions as soon as I finish this one. Then I'll take you through anything you want to ask me. So now, yeah, there is a disconnection that took place. And in order to fix it, most of the time, I'll just start by deleting this and delete that. And then connect directly there and observe. Ah, Lucky me. So at times you are forced to delete all the connections at top and fix them. Draw your entire circuit to its completion and then maybe fix it after. But if the time is up, submit. I always give it a submit. Okay? Let's play with it. Okay? R3, so 1, some S1 exit. It doesn't connect. Oh, you see, I like it when I make a mistake so that I can fix in front of you guys. Because you guys make more mistakes in a test, unfortunately. Yeah. So we need to struggle together. And you see here, it does show us that there's something happening. It has changed its sign eventually. I like that. I like the ability to change the signs and stuff like that. So now, let's go forward. Press, right? See now, it changes nicely. So I'm going to send it again, forward. See this one is connected, and then it comes. And you lower the returning again, even much lower, maybe here. Right. So now, extend. So now, lovely. So you see it's connected, and now it's going. Look this, I cannot take it forward again until it's fully retracted. This is what I was always explaining, that it will never go forward until it's fully retracted. Now the S0 is turned on. Remember the S0 for retraction is it's in series on the changeover section. So now you cannot work without, you can't basically, how can I put it? It cannot extend without the series connection be fully connected. If it was a parallel, you remember on parallel, we made the push buttons themselves to be parallel. But when we do the series, we're making the changeovers in series. I think you should note that one down, the difference. I've never really considered to think about them, but I think it's the main difference between the series and the parallel is that one. Let me go to the. Oh, let me see. Yes, discard changes. No. Save the changes. Okay, then we'll just save the changes. Is fine. Let me go to the booklet very quickly to check if what I'm saying makes sense or not. Guys, I did load the videos online. You can refer to them. I'll always add the new videos under this tab. Yes, they don't want to show here because of YouTube is blocked YouTube in here. So yeah, I'll always add videos there for us to, what am I doing now? For you guys to start with. So exercise 7. So they use the proximity sensor, but they never said anything about proximity sensors. Okay. But they should have addressed us on proximity sensors. Because this one, the one that we did, represent the systems whereby they are sitting outside. You know? Okay, I forgot my, let me check out my cylinder. And on the memo, they are showing a proximity sensor. So now I see that I'm going against what I was saying, so I will have to bring you back to life, up to speed. Uh, okay, I'll take a roller lever, only one, and I need to go to the video mode. Let me go to video mode. Let's go to video mode. Yes. Okay, is your typical, this is your roller lever, but you do find it as an electrical circuit. I don't know where is my electrical one. Oh, it should be here. Roller lever electrical, where are you? Got it. I must buy a lot of these. So this is electrical one, as you can see. So okay, so I guess the symbol says a lot. I'll start using it in the form of a changeover. You see the symbol, they're using a changeover, but I wouldn't penalize you for using the switch that we are using. So I will make that amendment now. So now, this one will work outside the cylinder. So, oh, sorry guys. Thank you. Okay, let me lower this part and this one is irritating. Number one. So now it works outside the cylinder, and I was talking about the circuit. They want us to use the changeover. So now we are sorted. I will start using changeover should we find ourselves needing to use this type of sensors. So these type of sensors, they sit outside, they sense the location of or the position of the cylinder rod from outside. So when it's fully extended, maybe you want to measure the fully extended position, and when you want to measure the fully retracted position, it measures from outside. But we have what? A conveyor belt. So it doesn't make sense to use these sensors. So you must use the sensors that get, this is the one, these ones. So you are able to shift them around on the cylinder board, as I explained in several videos. So now let's fix that, because I know connecting that cylinder is that proximity sensor is a challenge. Normally the book tells us that we are dealing with the proximity sensors. I don't know why they did it. I'm surprised, like it does cover that. Let's see. Limit switch, it just said limit switch, because even the previous one, I believe it was a limit switch. But you can't honestly hear, you can't honestly, it won't work. It will complicate the entire system. So yeah, they're not talking about proximity sensors. You use a proximity sensor, it's not a problem. Let's change this to a proximity sensor. If we're doing a very same system with roller levers, they call them roller levers, these things, we were gonna use this setup. So I have to change it to a proximity one. You see this shifting that I'm doing, the amendments. I love the fact that I get to do amendments. They are a problem, a serious one. From here, I'm going to find errors, and that's what I want to show people how we deal with errors. First and first, focus on the correct circuitry, then you'll do the errors later on. So now, proximity sensor, you find it under measuring instruments, no, electrical controls, where's my sensors? At the bottom. Okay, thank you. Let's see here. Okay, let's close. Oops. Let's see now. Switches. Valve, okay, electrical controls. Where are my switches? What's happening? Under solenoid operated? No. Alright. Oh, here, yes. So, and then it's under here. Yeah. Hey, this thing. Imagine in a test, it shows you waves. So, look here. They say magnetic proximity switch. You see that? So, what it means that the base of the cylinder rod is magnetic. What I was explaining exactly. It's my first time reading that way. I've been cruising without giving it attention. So normally you need a space in between here, a lot of it. Uh, and this is going to create a lot of errors, but that's what I want. So now we connect this there and that there. And then we connect this there and that there. So we're no longer going to have that sensor, but proximity sensor. Now they can just say P0 underscore retracted. Yeah? So the numbering is important when you are creating a circuitry that will be so big. Yeah? The numbering is very important. So P0 there for proximity retracted. Okay, so immediately you change, and keep in mind, it's a three cable system. Yeah, the 0, the 24 volt, and the one that goes to the proximity relay, meaning the one that goes to the relay. So you use 3 cables. So it's blue, red, and black. So now, as soon as I change this to P, the proximity will connect. You see that? I'm not sure if you saw that. When I just change this one to P1 for control, you see it breaks. The circuit inside, it connects. So, all right. And then there's an up sign here to represent that it is indeed induced at the current moment. It's connected, okay? And then as soon as we hit start, sorry. So as soon as we hit start, in the history of this lab, I myself failed a lot of times. Ne? But I've never seen a lady fall. Started using the lab since 2011. Never witnessed a lady falling. It was always guys. 11 years later, it's still guys. If I sit the whole day in the lab, it will never end that day without me falling. So we men, we can't sit. Yeah. So the proximity connects there, and then another proximity will have to connect at our P1 position, proximity 1, and then these changeovers remain. Then the sensor here becomes also a proximity sensor, and I need to go back. You see now, because I want it to fit nicely, and I have to always go back and forth. This one I think I'll do it like this, because otherwise I'll have stuff connecting too much. So this one like that, and we'll find there because we need a proximity sensor, another one that will come here, and then this one will become P1, and it's not connected at the moment. Okay, and then I then connect. Expect to see errors. Okay, but I don't think I need anything on the other side. Okay, is this an error what? Because look, it's okay. I think it's a. I hope it's not going to give us errors. All right, and then nothing changes basically. Say it start. Wow, it connected perfectly, seamlessly. That's good. I thought we were gonna have issues. So, Usol can go up now. So that I can, yeah, and then I really expected a lot of errors. So it means it really takes a lot of experience to do this thing because I've been doing it like forever now. So now we've changed now to the correct secretary and push start. The same thing is going to happen. The same thing. Then it has to come back. Uh, uh, P1. Wait. P1. P1 retract. Okay, I see. So it's fully extended, but this is not actuated. Do you see that? I wish they could allow us to amend on codices. You would just amend live, and nothing gets affected. Unfortunately, here it has to, because this is extended position. Okay, this is connected. Then it lets it go. And remember, it still can't connect without, yeah, it can't go forward without it being fully retracted. So there's the flow control, the one-way flow control. I deliberately placed it there in order for me to demonstrate this. But otherwise, if I remove it, the thing will go and you won't see. So you won't learn anything basically because you can't see anything. All right. There are two hands on the online platform, right? Okay. When naming the components of the function correctly, should we know the specific names or can we name them however we feel? Okay. You see, one thing I can tell you, a relay is a relay. Ne? Then a simple way to do a relay is to say R1, R2. And a solenoid valve or solenoid or actuator is always a solenoid. Proximity, I used P0 and P1. So I'm kind of coming close to the real meanings and names because when we move to uh, factory IO, those terminologies will move with us. So, and these are their stuff. If you go to any company and say, I want a magnetic proximity sensor, and you give them the spec, they will, first of all, the moment even you type on Google proximity sensor, you're gonna get it. But if you use the terms that are used on this sensor, on this answer booklet, where is it? You're not gonna be happy. They use BG1, MMS, MM1, BG2. You guys, like you can see also MB3, MB3, KF as like it's a relay. Just say R1. What this book means is that the guys from first to in Germany, Germany. I don't know what is a push button. Like let's say if I were to abbreviate a push button in German, what would I do? So it makes sense to them these BG stuff like that, the KF1 and stuff like that. They make sense for them, but do they make sense to us? No. They might have abbreviated from German, and it is possible. You must know one thing: Germans with English, there is a huge gap to a extent that even if you go to their website, I like because my master's is based on automation of laboratories. You understand? So at times when I read somebody's article and I see that he's working for a certain university, I get curious. How is that university now? Because I've been reading maybe an article in 2016, and I'm like, okay, I can see we're building this small lab equivalent to one in 2016. Now, what do you have? Then I go to their website and I check. And obviously, if it's written in Dutch or whatever, German, whatever, you have to opt for the translation. And yeah, not everything gets to be translated. So to show that even some facilities are still like when because normally I would go to their labs. I want to see labs. You can go on their website and see their labs. Everything is renamed in German, although I've opted for translation, you see. So it is possible that when they do the translation, these abbreviations get to be left behind. But let's use a simpler way to handle them. Okay, and then another person with the hand, I couldn't reach his name earlier on, and a lot of people here, and I forgot the gender. It's Kasago. Kasago. Kasago, you can unmute yourself and you say something.
Person. Can you please go back to
Yes.
the
Say, how
software?
are you?
I'm good.
Yes.
Can you please go back to the software?
Can you go to the software? All right.
Okay.
Okay.
Apparently,
Apparently,
oh,
oh, what's wrong?
I'm echoing.
Oh, sorry. I must, I must, okay. I must mute myself when you talk. I'll mute myself when you talk.
Okay. Apparently, you explained this one way. What's its name? One way valve. According to my understanding, one way valve allows a direction of fluid in one way direction. But then this one it changes. I don't understand why it does that. And then at the same time, I want to understand the purpose of the changeover switch. I tried to do a research on them, but I didn't understand them.
Okay. All right, thanks. All right. The one-way control valves, what it means in simple English is it only regulates the pressure only in one direction. The other direction it doesn't. Because if it could do it in both directions, it means that we only want to use one control valve to control the extending and the retraction of the system, and in which it's going to backfire. Because if I want to extend like right now, if you look at the direction here of this one with S goes like this, and then instead of being subjected to the regulator, it is able to penetrate this side, and then it pushes the ball up, and it goes and push this cylinder as quick as possible. But now, once it now starts to retract, if it comes again to the ball section, it can't penetrate, the air can't go through, then it's subjected to be pressurized. So meaning that it goes to the regulator, which is your normal, it's a valve also that you normally, you can, I can show you an example if I will find one as quick as possible. Hey, you, where is it? and I found it. Although it's too small, but yeah. Who's the camera? You come here. Yes. Right. So this is it here. So they're making them smaller nowadays. So what happens is you rotate here. This is a valve. Then it will only how can I put it? It will only regulate the pressure in only one direction. The other direction must always be working. Why? Why is it so? Okay, I'm sorry, I couldn't show you that. Let me pull up this. Moving between two screens. Yeah, because I don't have a big team such as MakeG who make sure that if it shows a certain thing, they make sure that whatever thing appears. Now I'm a DJ and everything. Like, yeah, I'm my own producer. So now this is the knob that we use to regulate. So we don't have it as an electronical as a thing here, but it is possible that we can find it as an electronical device actually, so that you control the opening and closing of the valve. It's actually a valve as well. So it's a typical valve as well that regulates flow of air only in one direction. And I think I will do a similar system in analogs when we are controlling the tanks. You will see it very soon. So let's then put another direction now. This guy is making us to clearly clarify this thing. I will. So let's put another one this side. I like to copy the very same one, copy and paste. Right? And there. So now, if look at this air is able to penetrate this side and push the cylinder back. If the air, no, if this, let me turn it around, I want to turn it around to 180. Now it's going to be interesting. If I were to put it like this, the air is restricted. And what are the possible dangers to restrict this? Because remember, this is a normally retracted position that needs to be there. So meaning that it needs to be strong position there. Like it needs to have the similar tension as the one for the spring to make sure to confirm that position. So if you restrict that flow of air going back, then it might stop the cylinder halfway and you're going to have problems. So because air is now being subjected here, yeah, and then it goes to the regulator and then it gets regulated, you're going to see problems. Let's try it. So now it needs to come back. So it's being regulated here and there. And if we were building it in real life, if you pull it by hand, it would come back, meaning that through dust accumulation, it will end up not remaining in that section that we need. So it doesn't get optimum pressure, basically. And that's the reason. Okay, and the other one, change over switch. My guy, I must go look for a relay. Why is it? Let me go look for a proper relay. I don't know where is it, but I'll find it. I found it. Okay. All right. Let me go back to the camera mode and show you the relay. Okay. My system is misbehaving. I can't zoom. I can't turn on the light. The circuit of this relay, do the auto thing, you know. Okay, it can't show it. Let me draw it. Can you get pen and paper, please? That's fine. Thank you. Okay, so I can't zoom on my thing anymore. It turns off, then it will delay me. I don't want it to turn on. Okay, let me go to the back. I hope you don't need. This thing is using the book from all ends. You see now. Can I write in the paper first? Okay, okay. Right, guys. Yeah. So I'm going to copy this circuit here. Guys, hello. We have, and I can't even turn on the thing, the bulb. Here, I'm redrawing this. This is A2, and then this is A1. Wait. This thing I'm gonna, can I get a darker pen, please? Or a pencil or something. It feels like a pencil instead. Right. So I have A2 there and A1. Literally on the circuit that is drawn on this relay. And then I have something like this, and then something like that here, and something like that. And this one connects there, literally. So, and I use the standard 4, and here they use 12, and then here they use 8, right? So, now, this is the circuit of a basic relay. It's enclosed like this. Your digital signals connect here. Digital signals, ne? Connect here. A signal, you can connect the two with a switch, manually, literally. Like you can connect the two with a push button, switch, whereby you have a switch like this, and then it will still work. Or you can connect to a PLC, yeah? Then you get your digital signal. Here you have, this one is a 250 VAC, yeah? And it push 12 amps. So okay, so it can push up to 250 volts, ne? And so when you go to these small ones, ne? They have the same setup, but they're pushing 24 volt. And the system, your A2 and A1, also pushes 24. So on this one, it's a simple system. You would never run a big motor here with this one. You would never run a motor with this one, a big motor. You would only run a 24 volt motor. But on this one, you can run up to 250 volt motor. So that's the difference. But they all have the similar systems. And even if you go to internet, the changeover switches, they're not changeover switches actually. They just changeover switches. But what happens is they are part of a relay. Once you have A2 and A1 or E1 and they change over, it's one circuit basically. So you can even go to internet and search for a relay circuit. Relay circuit. Hey, these are the ones who don't like that. I like the one that I can use. Relay circuit diagram. Show me the basic circuit. Don't show me these complicated ones. Okay, what is this now? And this is the second actually. I don't know why I'm not seeing the one that, but it is normally used for contactor. Let's say contactor and contactor circuit diagram. And on this one, I always get the one I want. Where is the one I want? This is the one here. Perfect. So now, and all these ones are the ones, yeah, let's go with that. These are the actual contactor circuits. So now A1, A2, and then these are your live, yeah? So your live here, and then here it's your zero, your negative. And then some of them, they have the open section, normally open, and some of them they have normally closed. So simple as that. And then this, yeah, that is that. They are correct. This is that. A1, A2, and all your phases of electricity currency are the same thing. This controls your motor. And your voltage matters. You need to know how much volt the motor runs, and you buy the contactor based on its volt. So if you come here and then obviously you have to read all of them. This is a 480. You see that this is a 230. So they vary 220 and stuff like that. Similarly with the relays. So relays, they also differ, 12 volts. And then you see here the circuit here on top of the relay. This is the same circuit. This is A1, A2, and then the connector there. So on this one, I believe it's a relay coil for a car. So they differ in the capacity they can produce. These are the 24. So that's why this is important to understand. They produce the power required to control a device, but the signaling power, it can be any amount of power, either 5 volt from a PLC or a 24 volt from a on our circuitry systems. Okay. Then now let's move on. I hope I answered. Okay, sir. Yes. Yes. On the ruler. Okay. We want to go back to the cylinder itself and we evaluate that. Let's go back to the cylinder. I'm going to do this. Okay. Now, you would definitely need a measuring tape to measure the distance from here to there. Okay. Remember, on the software, you don't do wiring physically. The labeling represents the actual wiring. Okay, so now I want to measure the remember this is a magnetic sensor, né? And then inside here there's a magnetic rod. Né? Its base actually is magnetic. So at the current moment, it's at its 0 point. Ne? So if I position this to this point, it means that when the cylinder is fully extended, that's when I want a signal to trigger. And then when it's retracted, I also push this back, then I get my signal at the end retracted position. And the importance of that is when these guys, they said we are pressing a push button. I can tell you now, you don't press any push button. That system happens because of the sensor. So what happens is it reads the number of bottles and it realizes that there's one or two missing, an incomplete box. Then what it does is it creates a signal and then it pushes off the crates. Yeah? And then it happens now as it continues to do that as it was extending, the conveyor belt doesn't do what? Doesn't stop moving most of the time. Then as it's about to retract, it gets trapped by the other product. Let's go back to the screen and so that I can show you quickly, not this the book. So as you can see, when it's fully retracted and the product manages to get here, then when it wants to retract, it retracts with these bottles. Imagine if they were here, somewhere here, and then it will hook them because you see it has a plank here, it has a flat surface, so and it's almost the same size as this box. So when the box gets here, and maybe you didn't do your measure your speeds, conveyor speeds and stuff like that, and your retraction you didn't increase the retraction rate, then it will hook this, and then it will create what is a jam. The plant will jam basically. You see now. So now we need those sensors to confirm our piston location. So if the piston is fully extended, we know that it's fully extended. When the piston is fully retracted, we know. And if it's not in any of those positions, then we can say let it trigger an alarm after maybe 3 seconds. Then there's a jam, and then the tap plant needs to stop. You get it? Do you understand, sir?
Kind of. I don't know. Like, okay, this is what I think.
Yes.
I've been trying to make sense of the whole thing. Can you please go back to the drawing?
Okay.
Like, this is how it works. See the start, the switch on the button.
Yes.
The switch on the start button, and the triggers the R1. The R1 triggers the R1 switch. The R1 switch triggers the valve, and then the valve like pushes the piston out. And then for the piston to rotate, the ruler triggers one of the switches.
The sensors.
Yes, triggers the sensor.
Okay.
And then the sensor triggers R3, and R3 triggers the switch up there, and then the switch triggers the other side of the valve.
So now you are now saying that we can't do this without the initial proximity sensor, is what you're saying. Yes, you are correct, but remember what we are saying is that we need to confirm whether the cylinder is fully retracted or not. It's a fact that it will always extend whether it's fully retracted or not. But problem is when the system is jammed, remember the book says, what is that problem? Problems occur repeatedly with the setup used thus far. The push button is not pressed long enough, and as a consequence, the single acting cylinder doesn't advance to the front end position. Yeah? And then the ejected beverages crate become jammed in the ejection area. So the problem that they face is that the system doesn't fully extend. Okay, so we now created it to fully extend by using a double acting cylinder and a fast two-way valve, a double pilot, because it can latch. So it will definitely, by just pressing that push button, it will extend and remain in the extended position. Then we confirm that we are extended. Yeah? Then we come back, we retract. But if we can get jammed while we are retracting, what happens then. So we won't be able to tell where is the position of the cylinder. Is it in the middle or it's fully retracted? You understand? Because you just see products piling up, piling up, piling up, piling up, and you can't resolve that issue. So now when you put the sensor, then you are always sure that it will always be able to extend again. And if it's not fully retracted, it cannot extend. We will do this example. I'll have to, because next week I won't be doing anything. I'll try to do a video on it on Factor O and try to simulate the problem. I will try. Not promising, I will try. Because on Factor O, most of people, when we teach with one product, yeah, to moving on the conveyor system. But when we test with continuous products coming in. So I would try to create a similar scenario whereby there's a jam involved, and then you'll see that it tends to be a problem. All right. And the other possible solution would be once the cylinder is extended, the conveyor belt must run at a slower speed so that it doesn't reach and block the cylinder when it retracts. So now every time the cylinder is on motion, the conveyor runs slower. So that's one of the buffer strategies you can use. And we will try to demonstrate that on Factor O. Factor O, we won't do it here. We'll do it in our 32-seater lab. And those with good computers, I am begging you, use your own personal computer. Maybe you can sit here, use your own computer, and I'll be teaching from 2K to in our 32 labs computer, because then we won't need to connect the computers on internet. I don't really know. I told you, Factor O, we don't have. Yeah, let me not, because this is going to YouTube. Let me not disclose. But you get me. Okay. Yeah, I see hands. Yes, minute. Okay. Let's go. Let's go here. Let's go here. From the question itself. It says, advancing, extending, can only. When the statement can only, you must always highlight it even in the text. So they're telling me the condition. It must only. So basically, the piston must only extend when its rear end position. So what does that mean? Meaning that you must confirm first that the system indeed it's at its end retracted position. If not, it must never work. So if we remove, want to take chances. If we remove R1 in the whole system, the system will do this. Watch when it gets retracted. First of all, did I press the push button? I didn't. Yeah. So I was supposed to increase the pace both directions. You increase the pace, so as you can see. I removed the relay switch of the push button, and this is what it does. See now? So, yes, it is confirming that it's at its end position. But if I remove the relay one, it will go forward instead. You see? And even if I were to do these systems in parallel, it was going to do the very same thing. So I can't do them, I can't even connect them in parallel. So they must be in series. So R2 is on currently. Yeah. So if I only use R2, the system starts to push products without my command. And involuntary movement creates accidents in companies, and you get fired. When something just start to run by itself after you start the system, you don't press any button, it just runs. You have a bandsaw that's up to the CNC, you have a milling machine. Those things are very dangerous. In automation, you have welding robots. Have you seen our 3D printer house?
Yes.
Do you know called what's that building? Synagogue building. Delays rest. I don't know how to explain. By what? Okay, do you know optometry? Like eye doctors here. Behind them, yeah, there's a 3D RDP house there that they're building with a 3D robot. Yeah. So one thing I can assure you, I don't think that robot can sense its location and stuff like that. I think it just moves, knowing it knows where it must go, but I don't think it will tell whenever there is a human being next to it. I didn't ask that question, but I don't think. And if it does, it will do it because there's a sensor. Yeah? So imagine that robot, the sensor is not working, the one that detects objects in front of it. What will happen to that robot? But guys, that robot is huge. It's the same robot, it's the same size of the robot used to lift Fort Everest. And it just place it and put it there. That robot is huge. And imagine if I take a Fort Everest and then, we release it from on top, and then, yeah, it will do disaster. So that robot is very strong. And you cannot allow it to do involuntary movement. You cannot, as a engineer. And since while we are dealing with this, these are hydraulic pneumatics. Hydraulics have more power. Hydraulics have more power. Remember, hydraulics are used to carry containers that are full most of the time. Hydraulics are used to carry bricks, like a pallet of bricks. You know that truck that comes and lifts bricks and put it on the floor? It uses hydraulics. Forklift uses hydraulics. All sizes of forklift, they use hydraulics. Whether they are powered by diesel engine or they're powered by electricity, they still use hydraulics. You get it? And imagine that a forklift forks, they extend, they go down, they do all sorts of stuff. Involuntary movement is extremely dangerous. And therefore, that's why most of the time there must be an emergency stop button that latches. So when you press it, it latches. So that if the problem was created by a sensor malfunction, the signal of that sensor doesn't restart the process. If we are brave, if you are brave, go look at the CNC, the lathe accidents. Just Google the picture. You'll find the most horrific picture of all time. If you are brave.
So, sir,
Yes.
R1 allows you to operate
The push button. Yes. R1 allows us to operate this with a push button to avoid involuntary movements. Yes.
How do you know if you should have said
Two relays. Okay. That one is straightforward. Let me guide you. Let me guide you. The push button, né, must have its own relay. Né? One relay is connected to one device. You can't multitask them. So once you say push button, you must have its own relay and its own changeover switch. Are we clear? And then this could be in real life. This could be two relays. So what happens is this is my push button, this is my sensor. I connect them in parallel. Then I use their actually no. In real life, I suspect. Yeah? I suspect. Let's do this. I feel like in real life it would be like this. When you are, especially for PLC equipment, oh, and then you're gonna have R1 here. No, but it needs not. It's not gonna. No. Yeah. Look how its relay needs to be connected. No, you can't. Yeah. Because normally, because this one is a 3-pin, that's why it requires its own changeover switch. No, it won't work. No. Never mind what I've done. It won't work. Maybe back. No, it won't work. Because it's a 3-pin proximity sensor. If it was a 2-pin, maybe we were gonna be able to. Like for instance, I want to make an example now. If I were to use this kind of a sensor, and then I delete the weighting here, or I cut it out, okay, and I put it here, paste, okay, then this one is actuated in series with that one. And then I'm gonna need R1 here, R1, right? So now, okay, it doesn't want to work, so I'm gonna delete here and reconnect it and start. Okay, so this is already adjusted and okay, R1, R2, what's happening? Oh, here we don't have a, so we're gonna use one relay. In other words, which one must go? This one must go. Let's see. And then, yeah, it was gonna be like this. But I don't condone this. I think you're gonna have problems because we're doing what is called indirect actuation. So I feel like you are moving, you are more creating yourself problems because already the condition says indirect actuation. So this is directly connected to that. It's no longer supporting indirect actuation. And you must remember one thing: it is possible to do this instead. So once you start to delete there and something gets deleted in this manner, the whole thing went away. Let's hope it comes back. I think today we'll do only 2 examples because they are starting to heat up. Yeah, that's what I'm intending to do. Okay, we'll delete also this. So this can still work this is direct actuation. Do you see that? So the sensor actuates source 0. And the sensor is okay, at the retract, okay, at that. And the sensor, why is the sensor not anymore? Retract. Oh, retract. Oh, this is written, yeah. Then if you actuate this, you see what it do. So this is direct actuation basically. It's no longer indirect. So I'm giving you a zero if you do indirect. So must always be indirect. This is direct. So what it makes is from here it goes straight to the sensor actuates the the solenoid directly, and then now the changeover can also represent a PLC. The sensor can be a 5-volt sensor connected to a PLC. A PLC reads that signal. Then the PLC feeds to a relay. Then the relay feeds to the solenoid valve, the correct voltage. And that solenoid valve, it could be controlled by a 250-volt relay. But the signal came from a 5-volt. You'll notice the difference when we get to Arduino project. You guys have an Arduino project coming very soon. So I think Doc, when Prof comes back, you might ask you guys to group yourselves. Then we give you the Arduino packages. Then you, Maga, I want you to run my 380 motor, né, with an Arduino that only produces 5-volt. You get it? I want you to come one day to connect it. I will help you so that you can see exactly why do we have the systems of changeovers and stuff like that. So now what it means is, ideally we want the Arduino to control the motor, but if you do direct actuation, the Arduino wouldn't have the sufficient power because it only produces 5-volt. Then we use a contactor that is rated at 380. I think this one also can push the 380, if not mistaken. Yeah, it can push up to 660 volt. It's a very big contactor. So you come, you DIY, you see this thing in practice, I'll welcome you. Okay, and I go back to the normal circuit we had. Oh, look at this. Okay. So can we move to the next question and the last one? Because I can feel I'm also tired. So in this circuit, for the first time, we're introducing electrical latching circuitry. Latching circuitry. So now we know that the solenoid valve, 5-2-way valve, a double pilot can latch, but not the electrical part. You get it? The electrical part can latch. So now for the first time, we're going to latch the electrical section. That's why it's called electrical latching circuit. And then they say with a dominant braking signal. It should have just emergency signal come, or normally closed signal. Dominant means that that signal is currently connected. It's a normally closed signal. There was no need to say dominant. Thank you. When piece carriers are transported on a roller conveyor, one segment of the roller conveyor can be shifted with the help of pneumatic drive This makes it possible to transfer the work pieces carries to another conveyor. I have on my what you call this Flex.io, I have something that is capable of uh, picking up products from one conveyor, lift them up, and put them to the second conveyor. And I think it is very crucial for running plants that circuit. We will do it on Flex.io. On Flex.io, we will be using a lab that would be dedicated for extracurricular learning. There were some gens who came to me and said, oh, why don't we have SolidWorks here? Because not all companies are using in Autodesk, so some are using SolidWorks. And I don't know where they got the training at first. I was confused. Then one of my guys that whom I work with, one of the technicians, came and asked the very same thing. Why can't we put SolidWorks here? Because the university has a percent. I was like, no, we have overloaded the system. There's absolutely no need. And now my lab timetable is really fully booked. So there's a lot of people coming here. So there was no need for us to use this venue. And I was like, no, but I have a venue that the computers are not currently connected. We can connect them, all of them, and install any software that we want to try there. When I say any, I mean any software. And it will be our extracurricular facility, whereby either myself or me must always be present, and then the students DIY on stuff. They will use our own Windows, meaning that what is it? YouTube will be open. Yeah, because of we put our own Windows. The restriction of YouTube will fall off. Although I don't want us to use the network here, which I need to sort out Wi-Fi, because yeah, no, it wouldn't be a good idea to be on the very same network whereas computers are not protected. It will be miserable. But we can use antiviruses to alleviate that. So yeah, we'll have such a facility whereby you can DIY even your Arduino project. You will be able to go there and investigate and stuff like that. Computers will be powerful, running on 16 gig RAM, big graphic card, and so on and so on. So yeah, and it was required by X and this thing, honestly. They said, why are we not having such a space? So we are going to have it, and that's where we're going to teach you guys Electro. So this makes possible to transfer the work pieces carried to another roller conveyor belt. Okay, and then the piston rod of a cylinder is advanced when the push button is activated. All right, and then the piston rod is retracted when a push button is pressed. Yeah? Right? These guys. What happened to that dominant push button? You see now, they are now misbehaving. That is fine. Okay, a down empty cylinder will be used, and then the system will be controlled indirectly. Okay, signal storage options. Okay, analyze power failure. No, explain a NOT function. Okay, there is a NOT function. I don't know what the NOT function here is for, but it's fine. Pneumatic electric, okay, or what too much. This book doesn't explain nicely like the previous book. Honestly, it only gives me that it must be electrical circuit there and as a learning objective, and it doesn't talk about that the fact that the system must be able to latch. It's weird, honestly, or maybe it's me. Right. So the system, I believe, is going to be a single pilot. So let's start first by introducing the single pilot system. I'm going to use the one that I used now, this one, and use it car a pilot signal. Pilot signal. What am I saying? Pilot. Where are the cylinders? I can tell I'm getting more tired. Yeah. Is this article that I must finish that is taking a toll on my body? Good. We don't need the sensors. So you see when you delete stuff, that's okay. I no. Should I continue with it? New one, eh? Yeah, I should cover my code. Imagine it crashes like this and then you are left in 5 minutes. Guys, like, yeah. But I can give you 10 more minutes. If you know what you've done, you should be able to replicate it in less than 10 minutes. And full evidence of the that problem that occurred. I don't just give you additional time because of I enjoy it. Because it delays us from going. Okay? So now we know this one. This one cannot latch. You see that? And if one thing I didn't test with you guys was what happened on this one. This one has a latching mechanism, right? You see? It latches. I let go of it. Then I press this side, it retracts. Okay? So now we want to make this one to latch. No, it's the one, number 4. What is that? Number 4. Remember, we want to make this one latch. So let's go to sensors. Why am I deteriorating this fast? And I'm still going to type, guys, like honestly. Fatigue is not good. Still, of course, 99. So the rotation takes place at 180, okay? Yeah. So now, push buttons. So we have 2 push buttons, right? So if I am to create this, guys, this is what it means. This thing is easy. Uh, I won't let it. Um, okay, this one could be R0, né? Once you are dealing with a lot of relays. It's a common principle is to go to R0, unlike starting from R1, so that can correspond with how PLCs are operate. PLC's numbering doesn't start at R1. So this is my PB underscore start. And then, on the other node, this one is my PB underscore stop. Okay? And then it is normally closed. As you can see, it's normally closed. Okay? then R1, then this is sol underscore 0, and sol is connected to where it's supposed to go. Actually, that's all quickly. So you must always verify. I would encourage that. The memos won't help you in the test. Keep that in mind. Because I always change it a little bit. So the latch is not yet in. You see now? So these buttons are in series. Do you see that? These buttons are in series. And then when I connect it, it goes forward and yeah, but it doesn't latch. How do I then latch it? We go to internet, we look for, I'm gonna allow you to say, what happened now? Oh, okay. Let's see now, 12. The next second. Alright, I wanna show you a basic latching circuit. There's images. I don't know why whenever we look for circuits and then we see the most complicated. Okay. So I'm just gonna say, yeah, and why don't I get the one that makes sense? Here's it here. That and that. Yeah, here's the basic leg circuit. I got the basic ones, and then see more. So you see that input one normally open, input two normally closed, then output. Yeah. Then the output comes to become an input, and it becomes an output as a normally open. It becomes parallel to the input one. And then the input one is in series with input two. So obviously you know that if these two are in parallel, then it becomes series. The series has the power to stop everything that is happening there. You see that? The series will have power to cut the signal. How so? This R0, we want it to be there in parallel with the start button. Yeah, I've seen that there. I've made a mistake. Okay. I can live without that. Yeah. If any error happens, we'll resolve it. Change over switch, then connect it and connect in between the two. In between the two. So this becomes R0. Want to enlarge it a little bit so that it can make more sense. This is too low. All right. All right. All right. All right. There's an error here. And there's an error here. Right. Because I'm shifting stuff. You see, when you shift things, you tend to have errors. Just reconnect, be calm, and reconnect again nicely. Don't put yourself under pressure. So now we have a system looking at this. It's unfortunate I can't flip my computer, but this is what I've created basically, and it's similar to to this, but flipped. Yeah. So these two are in series, and this one becomes in parallel. And the signal will come here and it will go there, and you see. So let's start it. You see that? So it remains extended. So meaning that once this is extended, where's our this booklet? Huh? So this needs to remain there. It will work until it's satisfied. We are satisfied, then we'll stop it, and then it will come to its resting position and work this side. You see that? So once it's extended, we're working, and now we press this, it goes back to its initial position. And the whole thing is controlled through a latching mechanism. There is a question already on Blackboard. Let the person ask the question. Where is it? There was a hand. Okay, let's read. When, okay, no, well, okay, before I can let you talk, can we say, let me read here. Okay, what is the name of the, okay, for Fluid Sim, we are using a very same software, but for PLCs, we are using Factory IO. You're gonna get it. Don't worry, the second labs are on Factory IO. So, can I get the question? There was a question. Can the person unmute themselves and ask the question? Can the person unmute themselves and ask the question? Oh, lovely, number one. So, over here in the lab, we have any questions? Yeah.
How were you able to make your factory
What do you mean? It will how?
like when you would solve that, yeah, that one. Because mine it doesn't.
Sol underscore zero. I think it's just. Oh, the dot, yes.
Oh, you press it.
Yeah, the dot. Oh, okay, yeah. That's a very, very important question. Guys, Usol, we label him here on the. Uh, okay, now I can't remove the name. You press on the dot and it becomes green. You see that? I hope you all see even from home or wherever you are. Then you'll be able to write salt underscore zero. Any further questions? Just say. Yep, you will be wrong. Uh, Firstly, it was. I know. I think you complicate the second. How about you do it next? Then you bring it, then we talk about it. But I believe you gonna complicate the second. You will complicate the second. Because otherwise, it was in series, ne? If they're in series, it means that you can just connect that one there and then yeah, attempt it and then we discuss. I'll make a choice from there. But now you will have yeah, they are most likely. Okay, let's see. I will try to give you a benefit of a doubt by removing this and connecting this thing. Uh, yeah, the gentleman wants us to try something else. I will try it. So this becomes R1. Obviously, this is a stop button, and then these ones they become in series. All right. So that is connected and start. And check. Magai. Low polar weapon. The latch is here. Again, it will remain on. What you will do is you will break the circuit here only. It won't help you. On the other 5-2-way valve, and see now you're no longer harnessing the power of election circuit. Because election circuitry, it must always correspond to the latch that we are having over here. Input 1, which is your start, input 2 is your stop, and then your output becomes thingy. That's the power. This is basic PLC code as it is. When we start doing PLCs, this is will be your code. At first, I'll start with input and output. You see the difference. Then I introduce the latch. You see the difference. Then we start programming. Are we clear? You understand, say? You'll get there. Don't worry. Keep on practicing. Explore your varieties and consult with me. Must have my WhatsApp number, email, everything, so that you can contact me and you consult. So, guys, thank you once again, and thank you for congratulating me for messing up. Cost of living is very high, and I'm busy enjoying myself. All right, thank you so much, guys.